according to that study, which is from a peer-reviewed journal, which comes renewable energy.
Oh, wow, okay.
So according to that, we've got a $2 solar PV panel per watt.
Uh-huh.
We've got $1 for AHs, which is kind of green for me at the moment, for the battery. We got $1.5 for the charge controller. We got $20 for the components, and the lighting system is 10 cents a week,
Okay,
about $280.
okay. So, yeah, we could definitely compare our system to that. Just compare the
Well,
prices.
just the former system, I mean, how could we make that system better? And I haven't looked at the solar lantern. That they're using for LED lighting in Malibu.
In where? Oh, okay.
It's
Mm-hmm.
like a solar lantern.
Mhm.
I seen the picture of it, that was when I was designing, I hadn't really looked much into that, but that is the system that it has like a lantern device. with the solar panels. How can we make that system better? Because I was thinking as we went in, how we're not trying to reinvent the wheel, we're just trying
No.
to make it better.
Yep. Yeah.
So, wheel rolling.
Do you have like electronic copies that you can shoot me, or did you already, or?
No.
Just when you get back on your machine, just shoot that my way. I'll look at it. So I wanted to show you this. You were saying, how do you do a patent search? So one thing I just did, and I told you I'd show you this other patent that I currently have. It's patent number 7,647,848. It was issued January 19th, 2010. And so what I did, this is just, well, patent and trade. I don't know what the PA, I guess the PAT is patent. And the F, and the FT, I know T is for trademark. I don't know what the F is there. Anyway, it's uspto.gov. And, oh, patent full text, there it is. Okay. PAT full text patents, starting from 1976. And, well, just means they don't have the full text from prior to that. So I just clicked on number search because I already had my number. If I just go back to my document here, I'm gonna copy that, come back to the search. But that's pretty easy if you already have. God, I filed that in 2005. Yeah, I filed it in 2005. It didn't come to light until 5 years later.
That's when they like accepted it?
Yeah, we had to go back and forth a bunch of times. And there were all of these other, I mean, when we were looking at the one you found a second ago, there were all these other ones that came up too. It's just phenomenal. That's the number of other patents that the officer looked at before he granted mine. I probably found a half
What's the
dozen.
1976 one?
Good question. I don't know.
Probably a jump between 76, 78, 98.
Man, that's a weird one. That is so unrelated to what we were doing. I don't know. Yeah, I would have thought they would have cited the guys that actually. This is not an energy device. I'll just read it here. It says a base unit for integrating an imaging device such as an atomic force microscope and a manipulation device such as a nanomanipulator. The integration of the two devices permits one device to perform both imaging and manipulation simultaneously simultaneous execution of these two tasks increases the rate at which experiments can be conducted, thereby improving the throughput of the device. Also, the simultaneous execution of these two tasks allows imaging during manipulation, which may be desirable or beneficial in some circumstances. So ours might say something similar. If we go back to our gadget, this allows the integration or series wiring of yard lights for charging a battery, which then can be used to charge your lantern or run other devices in a microgrid fashion. Okay, what else do we need to look at from your email there, Adam? And then I wanted to look at Gary's.
It might be useful, is the STL file one, which shows another design. Somebody did, it's roughly the same size and shape that it might be.
Okay.
It's that grab CAD.
So this guy right here?
Yeah. This is kind of interesting.
Well, check it out.
There was some kind of a academic challenge to build a light out of a bottle.
Okay.
And so there's all these people that submitted designs based on solar lights built with bottles.
Huh.
But you said you were looking for an STL file that was
Yeah.
about the same size and shape.
Yeah.
So underneath the file, there's an actual STL file.
Nice.
So that shows another design too, which is kind of cool. It's not
So-
real pretty, but it's kind of cool.
Yeah, what do they have here? So they've got the PV up top. Are these their LEDs?
I guess so, yeah.
And there's some kind of media inside the bottle that makes that distributes the light.
I didn't get the chance to read
'Cause
on
I'm looking at this guy. It looks a little
No, I think the light actually, in the bottle.
Yeah.
You can freeze in the wintertime. You freeze the bottom of like a gallon jug.
water.
Yeah.
Mm-hmm.
Put a light bulb on the top of it and see it out at Christmas time.
Yeah.
And stuff.
Uh-huh.
I think it's just the actual coating of the plastic that contains the light in there for a second, and then it kind of makes it radiate.
Yeah. It's just funny that this would be so cantilevered off to the side like that. It just seems like a little unstable. All right, let's go back here.
There's an STL file for like the bottle shape itself.
Yeah.
Which I thought maybe was kind of what we were going after.
Yeah, for sure.
It's underneath that files tab at the top of the drawing.
But I mean, that would be really neat if you could cut, I don't even think you'd have to do that, but you could recycle plastic bottles that way.
Mm-hmm.
And use them for your lenses.
Interesting. I hadn't thought of, what are they, which one should we look at, the LED holder or the tube?
There's tube.stl and holder. I think tube is what.
Let's look at tube. 3D view.
Wow, if we could incorporate recycled glass into this somehow.
I hadn't thought of that either, that would be pretty sweet. So fancy. There's that, there's the LED holder. Okay.
That's just the lid.
Well, I think this is the one that's down inside the bottle, isn't it?
Yeah.
Yeah.
That's what I mean. It's just
Oh, it is, yeah, maybe just a,
stuff down inside.
oh, right, huh.
Cork or something that it
Huh.
can fit through the top.
Yeah. Solar panel holder. It's a cell holder though, isn't it? It's not really a panel holder. And then, solar system. So this is that's the whole thing. Yeah.
What's the 10 for?
Yeah, I don't really know.
Maybe that's where the reflection comes. The light will shine off that way. Sees direction.
I mean, it's got to hit, the sun has to hit this surface, not the back surface though, right?
Yeah. There's a whole bunch of these.
Maybe that's his reflective surface that we're talking about.
You know, oh, I know what it is. This thing is actually embedded in a roof.
Oh.
This is embedded in a roof. That the tin, it's like, why is it so wonky? I keep thinking the bottle's sitting on the ground.
Oh,
No,
I see now.
the bottle is embedded in the roof.
I see. Oh, that is cool.
Yeah, that's what it is.
So you just have a bunch of those.
So you just put the bottle through the top of the roof?
Yes.
The roof, and then you got your solar light?
Yeah,
That's kind of cool.
yeah. And someone, I can't remember who it was, I think Tim was actually, said he's seen these, less fancy. It's just, I mean, all it is just a bottle in a roof with some water in it. There's no electronics at all, and it's just, it's kind of a poor man's daylighting.
Well, there's no battery in it then.
No. There's no battery in this thing either. It's just the sun shines, hits the PV, makes the electrons, lights the LEDs, that's all it is. No, yeah, you're right, there is no battery in this one
Battery, no
either.
charge control and all
Yeah,
that.
yeah.
It's just kind of hole in the roof and make a skylight.
Yeah. I think what this was some kind of a student challenge where every student had to design a solar lighting system using 3D printed parts or something. Because there's a whole bunch of different submissions on the site for different kinds of solar lights. Yeah, it's weird to not have a battery because then all your light is, when there's already light outside.
Yeah,
It seemed to me like you said you wanted a file that was maybe a similar size and shape.
Yeah.
To what we would be doing. So
Yeah.
That's the reason that
Yeah, it's a good example. No, it's a really good one.
that's the reason that I did that.
It's a really good one. Okay. Yeah, so I guess I'm wondering, just want to go back to our little setup here. Because I'm yet to see anyone who's taken just your standard garden variety garden light, hook them up in series to do something other than just power a light at night. Let's look at a power. Let's do a patent search on that then.
So do we are we kind of moving now towards having a wired system rather than a portable system that you would move inside?
I guess I don't see the need to move it inside if you can just send a wire in there. What was
As
the
long as it's easy to set up.
Well, his, I think it was
Paul? Yeah.
His thing was the lantern. Set the lantern out and then walk into the house and you'll have that little lantern to go with you wherever you need to go. And that's why I've been working with that. That's what that was the initial thing I thought.
Okay, so we've got the lantern here. But the question is, does the lantern, so let's look at a couple different embodiments then.
The one that
So,
I was looking at, I don't have it here, but the lantern, the battery, the light, the charge controller, everything was in the one, looked like a little Coleman lantern, and then it had the PV cells separate.
Okay, so in the second embodiment is more like this. That's gone. This is gone. And this guy, let's group it.
It's just hooked to your PV cells, basically.
This guy is just kind of sitting out here. Like so. So the only battery is the portable battery.
Yeah. And I think it's a smaller than 12 volt. That's why I was thinking, are they 6 volt or 9 volt?
Mhm.
They're 9 volts. No, 9 volts is a little tiny thing, right? I'm thinking of the bigger, not the big square one, but the,
Those little lights only use like 1.2 or 1.5 volts, I think, of battery. But you could probably get bigger ones.
okay, we go back to the point that I'm saying, nobody's gonna take a 1.5 volt light bulb into their house and try to do something in the kitchen with it.
Oh, I was talking about,
It's just not easy.
Not on a daily basis.
I was talking about the battery.
Yeah.
The bulb. But yeah, I agree, it's not enough light. And that's kind of part of the problem too, is that,
That the batteries are so heavy, I think it's the charge capacity that we have that's gonna make it different. I was looking at the lithium ion as opposed to a lead acid.
Mm-hmm.
You got better recharge, and, I mean, let's say, you don't wanna use this for a couple of days, throw it into the closet, it doesn't get charged. A lead battery, you're gonna lose capacity from it not being charged.
yeah.
But these lithium ions, they say that you don't lose as much. They're a little bit more expensive.
So there's a lithium ion inside this guy.
Well, not from the one I was, well, yeah, I guess there is. That was part of the study for that Lake Victoria.
So your lithium ions here. Whereas this guy is your,
That acid.
yeah. So I'm wondering if
For one, I was thinking the solar panels,
mm-hmm.
they don't have to be like that big. Have you ever seen those things that,
I mean, these guys, these little,
it's like a little bowl, it folds down, and you can take them and slide them out like that, so they're sit here, one slides this way, and the next one on top will slide out. So you slide all the way in a circle, or like a triangle, square shape, it would be more of a circle, I think,
mm-hmm.
or actually, like that, triangle, you can make it square, triangle.
So instead of just,
Just for reference.
Yeah.
That's how
Oh.
much space you've got.
Mhm.
Take one, they're all on hinges in the middle. Take one, slide it out like that.
Oh, yeah.
And the one, slide it out.
Yeah, I'm with you.
Like,
And you just kind of rotate, you could kind of quadruple your area.
well, yeah. And so you could get, the whole thing would be,
Yeah, I'm with you.
In the middles here, you wouldn't have your solar because you would never get anything. But
Mhm.
once you get it all out, you would have it. So you,
I like that.
It's cool.
I like that.
as opposed, it's the same theory as
Kinda like
if you had them
bio-
wallet together. They
Or
would
like-
go like so.
Mm-hmm.
Or like the petals of a plant or a flower that you put up.
Yeah, let's do, let me just draw that up really quick. Okay. So maybe, so on this chunk, you got this, your actual cell is maybe here. And then this guy, you group, copy, paste, and you rotate it 90. Like yay. And then, group, copy, paste, and then rotate that guy. It's not exact, I mean, something like that.
What-
I didn't
the first-
nail it quite right.
The first one that you put backwards, first one you copy and paste and put it backwards.
Oh. Let's just kill this one.
That one,
Yeah.
just rotate it.
Yeah. Let's give it a full 180.
There you go.
Yeah. Yes, they're all kind of, so there's no overlap there.
Do they necessarily have to be split?
No,
Because, I mean, you got some empty space in there. You could make the panel square, but everything else could be like a circle or, And I was
Oh.
also thinking,
because the cell, I mean, the cells themselves, the chips, you can't really do much about that. I mean, we're not gonna like start manufacturing our own
Silicon
wafers.
wafers. We should.
Yeah. But in this case, maybe what we want to do is do something like this. Ungroup. If we take this box and format shape, we can fill it. That's our actual cell right there, right? So what might work better on these?
it's a fold them out. Like-
Fold or hinge?
Well, hinge, fold, same thing.
Well, I mean, because when I think fold, the two surfaces meet with each other, but what you're laying out there, that's more of a rotation.
Well,
A spin versus a
I said
fold.
it 2 ways and you just quit looking at me.
Oh, okay. I see, yeah.
So you have your hinge.
Okay, yeah, versus a pin, yeah.
Basically, pull it out like this, and then you'd have them both over.
Mhm.
So you could optimize your area. I mean, you might. Oh, what's that?
Oh, yeah.
Half by 11.
Yeah.
Times 4.
Mhm.
And that way you could optimize your area
Mhm.
from like a notebook.
Mhm.
And then I was thinking you could have that set to where you could detach it from the side of your lantern or something. Because I was figuring we went with the lantern, the solar, the lighting system, as opposed to the battery system. But then again, it all comes right back to the thing that I think it would be better to aim at the camping people as opposed to people that are on the grid already. I mean, sure, we can say, yeah, this would be really neat, a novelty in your house. You won't use you won't use as much electricity for a full night as one of your 100-watt light bulbs in your house. This will take care of that for 8 hours. And you won't be using that, but you're gonna go camping, just throw this in the back of your truck and you got tent lights.
Could it be,
Well, I'm just thinking there, you've got with the fold-out thing, you've got a lot of wasted space.
Well, yeah, I mean, obviously, you do
Unless
want
you did them triangular,
to minimize the wasted space, but, I mean, gosh, go look at any panel, and there's always a little bit of border around there, especially if you're putting a hinge on there. You know, if you've got your, you know, what are we gonna do? If we put a hinge in here, hinge here. I mean, you need a minimum of 3 hinges. This would be 1. Right, there's your kind of hinges. Yeah.
and then you can shrink your actual space up, so you didn't have all of that empty, dead space in it.
Yeah.
I was also thinking for the fold-out, if, instead of putting them square,
Mhm.
set them at 35 degrees off, so that the point, instead of you've got the flat area up, you got your points up, and then you can set a bunch of different layers so you can get all of them. Instead of just having 4, you could have 8 on there, and the bottom ones will fill in the space.
I'm not following you.
Okay. Take one of these squares and rotate it so your point's pointing straight up.
Oh, 45 degrees?
Yeah,
Okay.
45 and not
Mhm,
35.
mhm. Let's do that, so, new slide, duplicate. So this guy's getting a 45-degree rotation. Okay. And then all of them get that?
All of them would get that.
Let's just do this.
Here's somebody that made foldable panels that look like they just pull over on top of each other. I like your design better.
So, so is this what you're saying here, Gary?
Okay, now, if we lose all of your, see, what I'm trying to do is compact this more.
Mm-hmm.
You've got all of this space here that you're not using.
Oh,
You're probably
yeah.
gonna have to have that there, and this here, but this would be over here.
Oh, I see, so just,
So we wanna
Just squish
lose
them down a
all
bit.
of, all of this empty space that we're not using.
mm-hmm.
And that would, for one, it would make it lighter, it would make it more compact.
So you're saying like you have a little less support material?
Well, not support material, just be empty space that you're packing around for nothing. Because you could always take on,
Yeah, I guess they're just looking at that a little bit there. This is all you're saying though, right, is to, yeah.
just so it's more economical.
But I'm not sure
Before
what
you take
the,
off with that, before you
not-
copy and paste.
yeah,
Let's put a circle right here,
In
like
the-
a little circle hinge.
okay. Right in here,
Yeah,
okay.
okay. Now hinge them together.
So these are gonna pivot, right?
Yeah, they're
Th-
just gonna open up from that one, and they'll pivot all the way around.
Gotcha. I'm gonna move that out of the way for a second. Make sure I got this grouped.
So could that hinge also be?
See, you could actually do that with your,
Oh, so this little bit of overlap here, is that where you're going with it?
that's where I'm going.
Okay, cool.
Would the hinge be the electrical connection between them also?
Oh, yeah.
It's gonna be everything. It's gonna be your electrical connection, it's going to be your, output. It's probably would house your charge controller and, what's the other part? Might even be able to put your lighting system on the other side of it, but I'm not for sure about doing that yet. I'm just trying to compact the solar panels in a way that nobody else ever has.
Yeah.
And then you're pretty much taking whatever size you're starting with and tripling it for your collection, PV collection.
So let's do this. So you're basically going from this to that, right?
Yeah.
I'm not sure what the 45's getting you, but it doesn't matter. It's-
I was just trying to get rid of all that extra space that you put in there.
Mm-hmm,
I was trying to explain it.
yeah. Group. I guess what I'm saying is like, it doesn't matter how this is oriented, it's the same area.
Well, when I was looking at it, I was thinking that if you were gonna have that empty space in there, we could try to fill it with something.
Oh, this stuff, yeah. So I guess you had like the hinge idea, so let's just kind of, like, let's go with this guy. Let's take.
Well, do they have,
Because that's two things to evaluate. One is like, what's the, because this kind of comes down to a packaging issue and how you sell it in the first place, right? Because you don't want to have some big bulky packaging too. You kind of do want to have it compact and minimal consumer assembly, some assembly required, but minimal assembly required. This might be a way just to, like you're saying, keep the post integrated, keep the electronics integrated. And maybe it is something where the consumer could just keep expanding his own little system without ever having to hire an electrician to go up on the roof. I mean, it might be a new,
Modular, like you just keep building onto it?
yeah.
yeah, the system that I was thinking of, you won't get any more space, compaction of the space. Because I was thinking,
It's pretty slick though, man. It's good design.
Yeah.
It's good design.
I love the fold out. Yeah.
Mm-hmm. Let me just copy this page up. I'm just going to kill this. Paste that. No. Group, ungroup. Kill that. Rotate this back to square. Let's just rotate her back to whoops. Both of them back to square. Just to complete our little thought process here. Take this.
I'm thinking maybe you get like 2 volts out of the whole, the 4 squares would add up to about 2 volts.
Well, only two, I thought we were at 1.8 for a single, no?
This is in this example, there's 4 cells make 1.8 volts. A
Oh,
single cell is 0.4.
yeah, that's more like it, yep.
That's where you get the 2, is basically 4 times a half.
Yeah, that actually is much closer to reality. That's what we're coming up with when we built that solar car. So each one of these, if you're gonna, so you'd need 6 of these to hit your 12-volt standard, wouldn't you? You'd have to buy a half dozen of these bad boys to get to your 12-volt standard. Okay, I can live with that. I'm just going to put these hinges, because this could also be, like we just saw in the patent application, different embodiments of the same idea, right? So you kind of got your butt covered. One guy was like, oh, no, you need a pivot. And it was like, no, you need 3 hinges.
If you took here, put your hinge here,
Mm-hmm.
now you open this up and you had one of these with like this, you had basically two of these
Yep,
hooked together.
yep.
So that would be 2 of them. We need 6 of these?
Well, I think if 4 cells is going to get you about 2 volts, because each one is like 0.5, 0.6 volts. And so to get to a 12-volt standard, which is, we need 6, we need 24,
I wonder,
Unless you made it bigger, well, yeah, if you could have bigger cells.
they would accordion down. One would hook on this side, the other one would hook on this side, and the other one would hook on this side, and the other one would hook on this side, and the other one would hook on this side, and the other one would hook on this side. They'd accordion down like this. And when you pull them apart, and then you'd start opening them up, all separately. Which would give you like a stack, they'd be a stack.
to get your 24.
Yeah, instead of, see, they'd accordion down like this.
Mm-hmm,
Once you got them opened up,
mm-hmm.
then they'd have their little round hinges here, or maybe here or something, and you'd have 4 of them connected here, and you'd open them up. But I don't know how you'd open the middle ones up.
Mm-hmm.
I'm just trying to make it one package.
Yeah, for sure. Oh, I see, instead of 6, so to sort of avoid having to do this little daisy chain.
Yeah, you just have one little handle that you pack down and just open it up, flip them out, let them go. I'm thinking of a flower grower though. It's kind of what I'm looking at.
Mm-hmm.
Kind of a biomimicry kind of thing.
Mm-hmm.
All of that stuff.
Yeah.
You know how it kind of opens up like this?
Mm-hmm. Mm-hmm. Well, that's a good little folding problem. All right, so where are we now? So I think we've got a couple different ideas going. Let's go out there. One thing I wanted to do is to see. Let's see here. What I want to do is open up recent. Where's recent? Oh, to go open. Narrative, quiz 1, narrative. There it's. File. Open. I want to do big 2 lecture notes. I want to find the 12-volt ANSI standard and see if there is one. This might be a reasonable place to start. Comparison versus ANSI IEEE for low voltage switch gear. Scope of ANSI C37 covers metal enclosed low voltage power circuit. This is more switches, which is relevant. Individual country standards is the template.
Fluorescent something?
Well, ANSI decides metal enclosed low voltage power circuit as assembly. Closure to have a minimum. I don't know what IP2X rating is. Ingress of a solid object. So you just don't want crap to come in. Duty cycle. Gosh, that's a lot of current for low voltage, 5,000 amps. Low voltage. Yeah, this is going to take a little more time to build. Because I think one thing we're going to have to show is that our device meets some standard, and we're going to have to find and cite exactly what those standards are, and it's going to be ANSI or UL. I'll just save this thing. Let's print it as a PDF. Print. Grants, courses, lab. I'll save it in here too. Just remind ourselves to dig into it. PIC 2003. All right, so there's that thing. Also, ANSI standard, multimeter. We should go dig through the. So if we looked at everything you said, we looked at the STL, we looked at the patents, we looked at.
I think the technical feasibility is going to depend on kind of where we go with it and what size the lights are.
Yeah.
All that stuff.
Yeah. I guess I can't quite get away from the idea of having something that empowers the homeowner in some unique way, where they're supporting the PV industry by buying photovoltaics, they're taking an active role, and I think that's more what this people, prosperity, and planet is about. Is so empowering people to take active role in their own energy security, right? So this is sort of beyond the candle model for lighting, beyond the generator model, the diesel generator model. and you've got some references on that too. Model for remote,
Yeah, I pretty much paraphrased everything, so.
beyond carbon, right, it's another thing we're looking at. And then re-engineer, I think we need to throw something re-engineering in there, 'cause I think that's really what we're doing. It's a student project, re-engineering, existing system. And I think the prosperity thing, we have to show the cost competitiveness, and you've already done a lot of that.
Done a lot of analysis for using LEDs as opposed to everything else, fluorescence. The closest one that comes to fluorescent, but that's like X'd out with the fact that you gotta use phosphorus and mercury to make fluorescent. Light up.
So we'll throw a little table in on that too. Is this gonna be Gary? All right, so maybe, let's just go dig through the lab here. We got like 20 minutes of lecture left. I want to say that we left some PV cells in there, and we should have some multimeters, we might even have some phone cord. I'd like to look at line losses. So when we start to look at the nitty-gritty of the design, like, do you string them out like this? Do you go with more of the folding thing to keep all the lines shorter? Obviously, where's the battery? Are there two batteries? There's a big fat one sitting inside, and then another one sitting in your little lantern, or do you skip the other one entirely? And I can even think of a third way. Then we'll go in the lab here. A third one might be where you have, I don't know the best way to draw this, but I'll just say insert
Those are only
shapes.
that big. The solar panels that we're looking at, we need 4 of them that are that big.
Solar cells?
Those are that, yeah, they're like, what's the size on those on that? Those are, I mean, they're little tiny things. So is what I'm saying is, can we hook 4 of them together into one little, make a little panel?
Oh, a mini panel with the 4 cells? Huh,
Yeah.
okay, I'm with you.
And we could open them up, we'd only get, we get 16. So we're making our 12 volts. Because we only need 12, right?
12 volts, yeah.
And so would be,
Not sure how big those are.
I think
those are just little tiny things, I'm for sure.
I think we have some in the lab.
Looking at, just from my reference to the ones that I plugged in my yard, that are just little tiny things. They're not very durable, they're not very sturdy.
Yeah. I was thinking another aspect, throw in some recycling by using glass bottles as the base.
I think that could be pretty sweet too, yeah.
Kind of throws in another.
What's
And
the cost of breaking the glass bottles down to,
Well, you would just use them as is.
And maybe the 3D printer, you get a 3D printed thing that pops into the bottle and then holds your cell. Could work.
I guess that might not be sturdy,
So here's another incarnation of this where you've got I'm just showing this going to the grid, right? So,
you're gonna have to throw a DC converter in there.
yeah, I know. Documents, courses. No, it's not courses. I'm putting this under grants. 2014 EPA concepts. All right, so we kind of have the three different concepts. This is kind of the original, like the bring inside, super simple, right? Isn't this kind of what Paul came up with? Your sort of bring inside deal.
Without the wires, yeah.
Were there no wires at all? You just bring the whole dang thing inside? Let me just, let's go even simpler then.
That was my impression.
So his idea was, that.
Pretty much.
Was that it?
That was my impression of what he was saying. Yeah, it was just put it outside during the day, bring it in the day.
Okay.
Pick it up and go with it.
And the PV is all on the top too. I mean, maybe the PV, maybe it's your little fold out in the day, fold in at night.
But we want to, you want
Do
to
you
disconnect.
bring the whole dang thing into your house? Or do you, I mean, maybe you do because it's going to be junky weather outside. I don't know.
Well, you want to kind of easy. I was thinking like, if you had something that you could fold out and the light all included. But my thought was more like more like a disc, like this. So you have something here. You come down to the other disc.
Mm-hmm.
Bottom, and these would be like collapsible in here. So you'd have some sort of collapsible material.
Yeah.
So that would collapse down. And you'd obviously have to have something over the top to house your light and your batteries and stuff. The batteries would probably sit up here, so your light would be down there. Then you have hook, so when you got done, your whole system, when you're looking at it and it's not lit up,
Yeah.
you're looking something like this that's collapsed down to a flying saucer.
Mm-hmm. What's the, okay, what's the, why does it need to open up though?
Well, that's just to save space. I mean, you don't, if you have this hard,
Yeah.
then you would just like have your base here, and that's, it just look like a lantern.
But the bulb itself is on top. No?
Yeah. You have the panels come out somewhere around here. Open up. So you could like have one of your four here, and one of your four here, and one of your four here, and one of your four here, so that when they opened up, you have
Oh, yeah.
sort of like, I'll show you the top of this round thing.
Mhm.
You have one of the panels here like this, and then one here like this. See, I didn't do it that much, just to show
Yeah,
you.
yeah.
And then over here like this, this one here like this. So somehow you can figure out how to open these up. You have to place these at different places. You have to look at the engineering, and then you can start opening these up. And have them all hooked to this, so you have all this space, and you come out and just kind of fold it all back together.
Mm-hmm.
And get your light out.
Yeah, no, I'm with you, Okay.
So it's all one unit. Because everything that I looked at
Mhm.
for even Africa, they had the panels and the lantern. Which you could always make if you just made it to where there was a cord you just unplug. Which is going to bump the price of it, but
The other thing we talked about was having some kind of a receptacle inside that you plug the thing into.
Yeah.
So maybe you have like a 6-pack receptacle that you bring 6 of them in, plug them in, and then run your microgrid from that thing. That's just another angle we talked about.
Is that
Maybe
sort
that
of,
would be like this.
it's just sort of this one, yeah.
That'd be a wired
Because I guess with the integrated unit, what you have here are, you have cells integrated with lantern, right? Just like you just drew. The cells are all part, and so so you're actually carrying the cells around with you. This one is,
Way go to changing the output.
this is separable. And I, like, there's got to be, so pros and cons we should look at. So one pro here is that the less likely to damage the cells. Yeah, dragging around. So light. So it's more complex, right? But so less potential cell damage. Cons, more complex. If we go to this guy, so the pros is integrated, simpler. Con, it's just the reverse of what we just looked at. Con is potential damage to cells. All right. With that, let's just go see if we can find those cells over in the lab. If they're not there, it means we used them all up for something, and we just need to buy some more.
Well, I'm also thinking too, now that I'm looking at it, since I'm going to collapse it